now that we know the basic idea behind hypothesis testing, it's time to put our plan into action and actually run a hypothesis test. Now, this is the first hypothesis test we're going to learn, which is the hypothesis test for a single proportion. Now, this sheet is a reference sheet that we'll use to run the test, and it's available also in the exam notes packet. It has your technology pieces up here for how you're going to run this in StatCrunch, your requirements needed to run the test, your hypotheses, your alpha, and so on. All right, so let's actually put this all into action, and we'll keep referring back to this page as we do it. So in a study from 2015, the Pew Research Center found that 1/4 of adult Americans paid for almost all their weekly purchases with cash. A credit union researcher believes the percentage has decreased since then. They conduct a poll of 1,068 random adult Americans and find that 18% of them make almost all their weekly purchases with cash. And this, yes, this comes out of a real study, actually, a couple real studies. All right, so the first thing we need to remind ourselves, this is a little review, explain why this study must have been an observational study and not an experiment. Well, that's a review of chapter 1 from ages ago. Experimentation requires random assignment. You'd have to randomly assign people to be in the cash group or the non-cash group or something like that. And that's very difficult to manage. So it would be very difficult. And you'll notice I'm asking about this, why this must have, instead of saying it was, because of course it was, because it's a poll, right? Polls and surveys are always observational, right? But it would be very difficult to randomly assign people to use credit cards versus cash. Some people don't have credit cards, so they can't use them even if you tell them to. Some people don't ever use cash. It would just be a nightmare, right? They're not near a place, they're not near an ATM because of whatever reason. All right, or an ATM that's in their system. All right, so now let's look at the hypotheses. So what do we assume to be true unless we can prove it otherwise? So that'll be, it's honestly step 1 of the hypothesis method. I'm just doing it up here, right? So if we look at our 6 steps, right? Step 1 is to create hypotheses, and so on, right? So we'll come back to other things. All right, so we need an HO and an H1, right? So we need to know what our null and alternative is. Now, first of all, 1, because of the section we're in, and 2, we don't know any other hypotheses yet. This is obviously about proportions, right? This is talking about a survey, it's talking about a poll, it's talking about the percentages of people that did certain things. So this is obviously P, right? Proportion. All right, now what proportion is it unless we can prove otherwise? Well, it's a little tricky to read, but it's in there. It's right up here when it says 1/4, right? That's the null hypothesis. That's from the past, right? That's from 2015. So we assume that value is still true unless we can prove it otherwise. So that will be 1/4. And once we have 1/4 over here, we'll have 1/4 over here. And then the researcher believes it has decreased. So that decreased means that it's a less than. I'll give that a little highlight there. All right. Okay, so we've got our hypotheses set up. Now, I wrote these with fractions because that is stated as a fraction. Of course, this particular fraction you could write as a decimal because it works out beautifully as a decimal, but a lot of fractions don't. Fractions that have denominators in the 3 or 6 will have repeating decimals, so it's better just to use the fraction. And StatCrunch will allow a fraction use, so we'll just leave it at that. But we can make a note over here if we wanted, that 1/4 is equal to 0.25. But again, I want to use the fraction on purpose because there are times where we have hypotheses that don't work out nicely as decimals, right? There are a lot of fractions that don't play nice. So, all right, now, that was step 1. We're actually going to do steps 2 through 6 down here at the bottom when we actually run the test. But I wanted to find the hypotheses first because we need the hypotheses to verify our requirements. Now let's look at that. The requirements are going to look very familiar to you. It's random, it's independent, and it's normal. But if you look at normal for a second, normal has a p0 in it, the p from your zero hypothesis, from your null hypothesis. So you kind of have to figure out what your zero hypothesis is first before you can check requirements. That's why I had us do step 1 here, and then I have us verifying requirements here, because it's a little out of order. All right, so let's verify our requirements. So random is given. It says so somewhere in here. Random adults right there. Sorry, you can see that. So random, so that's given. Given means it was literally written in the problem, which it was. All right, then we need independent. All right. Well, to be independent, we need little n to be less than or equal to 0.05 capital N. Little n was the number that was in our sample, which was 1,068 adult Americans. So it doesn't hurt to kind of make a note of that. That's little n. Sorry, my 1 got weird there. It got merged into my 0. All right, so 1068 is less than or equal to 0.05. Now, capital N is adult Americans. We've run into that before. We're going to say it's 210 million. It fluctuates depending on what year we're talking about, but it's generally going up. All right, so this is yes, of course, right? I'm not going to go find that number, but I know that it's huge, and 1,068 is definitely less than 5% of it, so we're good. All right, now we need normal. And this is the reason we needed the P0. P0 is this 1/4 right here. So we need n times P0 times Q0. Well, n was 1,068. P0 is 1/4. Now what about Q0? Well, let's remind ourselves. And it's in the sheet somewhere. I wrote it right here. Right? Remind yourself that Q0 is the complement of P0. Remember, P and Q are complements. They add up to 100%. So I'm just going to make a note. P0, Q0 are complements. So Q0 is 1 minus P0, which is 1 minus 1/4, which is 3/4. Okay? So that's what I'm going to put in right there. So 3/4. And then I'm going to go grab Desmos and find that number and hope that it's bigger than 10. That's StatCrunch. All right, so first of all, 1 minus 1/4, you can see it's 0.75. If I click the little fraction button over here on the left, that little circle with the fraction in it, it turns it into a fraction. So you can use decimals or fractions in this case, but a lot of cases you can't. You just have to use the fraction. So I'm going to use the fraction here. And then I want 1,068 times 1/4 times 3/4. And I get 200.25. Which of course is greater than 10, so we're happy. We have 3 yeses. We're good to go.